Chapter 8, Lesson 6, Quadratic Equations. We are going to continue to learn how to factor trinomials, specifically trinomials where, if you notice, the x squared term does not have a coefficient. These are baby steps. This is the simplest one. What we are going to do is do foiling backwards. So if we remember, when we FOIL, when we distribute both of our terms, we get x squared and then 4x, then we get 3x, and 3 times 4 is 12. So you'll notice our final term comes from the product of these two numbers when we multiply them, and our middle term comes from when we add those two together. Okay, so we will be talking, I will say that a lot. I will say the product of 12 and the sum of 7, and we need to find those two factors. All right, so then we'll put it like this, and look at there's positive 3 and positive 4. So I'm going to skip all that. You can read through that if you want. They put letters in and talk about product of m times p. That's this one, and this is m plus p, and so on and so forth. But it's really just makes more sense if you go on and do it. Now, they on this note sheet, I will have this awesome little T-chart here that helps break down the factors of the numbers, and but you don't have to do that. So if we're talking about two binomials that will multiply into x squared and 6 plus 16 plus 63, you know that the first two will be x squared, and they keep that pretty simple because they don't put a coefficient. And we know that the last two numbers will be factors of 63. So we want to think of all the numbers that multiply up to 63. Now, I know it's hardly ever going to be 63 and 1, but you always want to consider that. And then we've got 21 and 3, and then we have let's see, is it 7 and 9, right? Is there anything else? Not sure. Okay, and so because this is a plus, that tells me my signs are the same. They're either both positive or both negative to get a product that's a positive, and since that one is positive, they're both plus. So I'm looking for two numbers that have a product of 63 and a sum of 16. So over here, I put the factors. Then we got 64, then we got 24, and then 9 plus 7 is 16. And there you have it. So we can put in our 9 and our 7. Now, I could have put 7 and 9. It doesn't matter because multiplication is commutative. Always double check x squared plus 7x plus 9x plus 63, and 7 plus 9 give us 16, and there is your correct answer. Okay, so baby steps. Take a look at the second one. Down here, we're guessing and checking. That's what this is over here. So down here, I know it's going to be, x and x. I know that it is the same signs, and they both must be positive. So I'm looking for two numbers that have a product of 20 and a sum of 9. So all my factors of 20 would be 20 and 1, 10 and 2, and 5 and 4. That would be a sum of 21, a sum of 12, and a sum of 9. So there you have it. It's going to be a 5 and a 4 or a 4 and a 5. Either way, you can multiply it out, but you probably know that that's the correct answer. 1 minute. You come in. So if you turn your back over, I'm just doing a video. What's up, Joe?
We were just asking a question about our assignment.
Oh, okay. Give me like 6 minutes.
Okay.
Okay, thanks. All right, so moving on, take a look at this one. What's different about this quadratic equation is that we still have a product of 24, but look how this is negative. What that tells me is that two numbers still multiply up to get a positive 24, but when we add them, we get negative 11. That means the signs are the same, and they're both negative. So now I have I still know it's x and x, but I know that they're both negative. And I'm still going to be adding them together because they'll both be negative. So let's talk about factors of 24. Negative 24 and negative 1. We've got negative 12 and negative 2. We've got negative 8 and negative 3. We got negative 6 and negative 4. Oh, so many factors of 24. And their sum, this would be negative 25, this would be negative 14, this would be negative 11, this would be negative 9, oh, sorry, negative 11 and negative 10. There you go. And notice it is negative 11, so I know it's going to be a minus 8 and a minus 3. And that's your answer. Same thing down here. We've got x squared minus 8x plus 12, so we know that the signs are the same. They're both negative. And so factors of 12, 12 and 1, 6 and 2, 4 and 3. Which one of those will have a sum of 8? As I add them together quickly, 13, 8, and 7, it's got to be 6 and 2. Now, do I expect you to have to make this table over and over and over? No, I don't. I expect you to probably be able to do these pretty quick like. Okay, now, it's going to change here. Take a look at these polynomials. These polynomials have a negative number as our final term, your C term. So what that means is my product is a negative number, which tells me that my signs are different. We got one positive, one negative. If we have one positive and one negative factor and I multiply them out, my two middle numbers are going to be a positive and a negative. So this center number actually becomes a difference of those two because we'll have a plus and a minus and they will be a difference. So we're looking for factors of 6, 6 and 1, 2 and 3 that have a difference because one's positive, one's negative of 1. So this has a difference of 5. These two have a difference of 1. So we know it's 2 and 3. However, pay attention, it's a positive 1 in the middle, which tells me that which one of these is positive and which one of these is negative. You're right. The 3 is going to be positive because, negative 2x plus 3x minus 6. In order to get a positive 1 in the middle, I needed the 3 to be positive and the 2 to be negative. So there is our answer. So that sign tells us so much. That back sign tells us that our signs are going to be different. So we're going to have 1 plus and 1 minus. So products of 21, 21 and 1, 3 and 7, and I am pretty sure that is it. This one has a sum of 23, but a difference of 20. This one has a sum of 10, but a difference of 4, and that's the one I'm looking for. Notice it's a negative 4, so the 7 is going to have to be negative. The 3 is going to have to be positive because we got x squared minus 7x plus 3x minus 21, and that gives me a negative 4x in the middle. So there is the answer. Now, we're going to continue to do those. Most of your assignment will be factoring, and then towards the end they will ask you to solve it, just like we did on Wednesday. We're going to factor, set it equal to 0, factor, and then set each factor equal to 0. So take a look at this. It's already set equal to 0, so all we have to do is factor x squared minus 8x plus 7. There's only two factors to 7. It's 7 and 1. It's the only ones it can be, and it has a sum of 8, and the signs are the same, and they're both negative. So x minus 7, x minus 1 equals 0, which means x minus 7 is 0, and x minus 1 is 0. Goodness. So when we solve them, add the 7. When we solve them, we add the 7, we get x equals 7, and add the 1, x equals 1. There are our two solutions to that equation. On the last example, it is not equal to 0, so the first thing we're going to have to do is bring that 27 to the other side by subtracting it. So we get this new quadratic equation, and then we can factor it after it's already set equal to 0. Now this one, we have a minus sign. That tells me one's plus and one's minus. So let's think of all the numbers that have a product. And notice I didn't give you a table here. It doesn't mean you can't write it down. All the products of 27. Now there's not that many. 27 and 1 and 9 and 3. That's it. Which one of these two have a difference of 6? And it is 9 and 3. Because that 6 is positive, we know that the 9 will have to be positive, the 3 has to be negative. Set them both equal to 0 and solve. So add 9, we get negative 9. Subtract 9, we get negative 9. Add 3, we get positive 3. And there are 2 solutions. Now, I was going to give you a punchline worksheet, but because we missed a day of school, we're going to dive right in. You get a weekend to do your assignment. All right. Come on in, ladies. We'll see you later.